Hi. So today we're going to talk about fundamental theorem of calculus. So first, let me introduce you to some notations. We this sign is called integral sign. The integral of f of x dx. This whole thing is what we call indefinite integral. Now, when you have numbers below and above here on this indefinite integral, that's when we call this integral definite. So the integral is definite when you have, we call those limits of integration. So this is the lower limit of integration. That is the upper limit of integration. So this whole thing is called definite integral. Any function that is between the integral sign and the dx is called integrand. An indefinite integral, a definite integral. An indefinite integral, the integrand is x squared plus 3. A definite integral. Now, let's go to fundamental theorem of calculus, part 1. Okay. So fundamental theorem of calculus, part 1, is about taking the derivative of a function that is actually an integral. So you're differentiating an integral. Okay. So the function is g of x equals to the integral from a to x of f of t dt. So this integral is a function of x. So we call it g of x. Because it's a function of x, we can take its derivative. So the fundamental theorem of calculus, part 1, says if you take the derivative of g of x, what you're going to do is basically copy the integrand, which is f of t, and evaluate the integrand at x. So that's how you get f of x. So it's simple. Okay. So when you're taking the derivative of this integral, what FTC part 1 is saying that, so first you copy the integrand and then you evaluate the integrand at t equals x. So that gives you this f of x. So that's the derivative of this integral function. For example, I notice that here a is a number, right? So for example, g of x, usually the question is this: differentiate the function. So you have g of x equals to the integral from 2 to x of sin of t dt. They're not asking you to integrate, they're asking you to use the fundamental theorem of calculus to take the derivative of this integral. So what does the fundamental theorem of calculus tells you? So it says first, so the derivative is, so basically copy the integrand, which is the sin of t, and then evaluate sin of t at t equals x. So which just give you a sin of x. So that's what it says. Okay. Now, if you have a different problem, like this one, you have g of x equals the integral from x to 3 of 1 over 1 plus t squared dt. They still ask you to find the derivative. Again, the fundamental theorem of calculus says that because this time, so it says you so this integral can be written as you can flip the integral. You can flip. You can bring the top to be the bottom, and the bottom. What I mean is the limit. You can change limit of integration like this. So for this integral, the new integral to become the other one, to be equal to the other one, you have to put the minus on. So you can change the limit. The lower limit can become the upper limit, and then the upper limit become the lower limit. If you can switch this, then you have to multiply this integral by negative sign. So then, because of this, if you take its derivative, so what you do, but the fundamental theorem of calculus says that all you need to do is copy the integrand. So you still have the minus sign here. You copy the integrand, and then you evaluate the integrand at t equals x. So that means your answer is going to be negative 1 over 1 plus x squared as the derivative. Okay. So that's what this fundamental theorem of calculus is telling you in this case. Now, there is sometimes an integral like this where instead of x as the variable limit, it's like x cubed, x to the third. Okay. And they still ask you to take the derivative of g of x. So what happened here is you to apply the fundamental theorem of calculus part 1, which says copy the integrand. Okay. So here's since this is not x, you have to do it differently. Okay. So since you're not dealing with x, you're dealing with x cubed, what you're going to do, still the same thing. So the derivative is going to be, so you're going to copy the integrand, and then you're going to evaluate the integrand at t equals x to the third, and then you're going to multiply this by that x to the third, derivative of x to the third. Okay. So use some kind of chain rule to do it. So first you copy the integrand, and then you evaluate the integrand at t equals x to the third, and then you take the derivative of x cubed, which gives you a 3x squared. So you get what they have here. Okay. So that's a different. This is not just x; it's a function of x. That's what you do. So in general, if you have this is like a formula. If you have a g of x that is given as the integral from a is a number to u of x. Now this is a function of x, of f of t dt. So the fundamental theorem of calculus is telling you to take the function f of t, evaluate it at the u of x, so you get f of u of x, and then times the derivative of u of x, which is give you u prime of x. That's what we did so far. Okay, that's a fundamental theorem of calculus, part 1. Another example is that anytime you have the number as the upper limit and the function is the lower limit, it means you will put a negative sign. So you have negative times, then you copy the integrand, you evaluate the integrand of sin of x, and then you take the derivative of sin of x. Derivative of sin of x is cosine of x. So you get the answer is negative natural log of sin of x times cosine of x. Okay, so that's where we stop with fundamental of calculus, part 1. It's all about taking the derivative of a function that is an integral. Thank you.